Dear students, in this session we are going to see about what is potential difference. So now before going to this session, we will recall what is happening in the last session, that is electric current. Electric current means what is the rate of flow of charge is called as a current. So the current is represented by a symbol I and the charge is Q and the time is T. So the current is measured as a 1 ampere and the charge is coulomb. Time is second. So 1 ampere is defined as 1 coulomb of charge flow per unit second. Last session we have studied very important property of the charge, that is called as a quantization of the charge. Quantization of the charge means Q is equal to Ne, where N is a number of charge and E is the value of the one charge. The magnitude of the one charge is equal to 1.6 into 10 power minus 19 coulomb. We solve that what if the charge is 1 coulomb, the total number of electrons is 6.25 into 10 power 18 electrons. The very important point last session we are seeing is the current can be measured by a device is called as a ammeter. The very low measurement is milliammeter or microammeter. Now we are going to see about what is potential difference. See some natural phenomena. The water will always flow from higher level to lower level. The air will always flow from high pressure area to low pressure area. The heat always flow from high temperature to low temperature. Never the heat flow from the lower temperature to higher temperature, or the low pressure to high pressure, or lower level to higher level. The water will not flow. Similarly, the same way the charge will flow only from higher potential to lower potential. Now we are going to see that what is potential. Yes, charges will flow only between the 2 points which has a potential difference. One point is a higher potential, another point must has a lower potential. Now we will see that what is potential difference. The potential difference is defined as the amount of work done to bring a unit charge. Unit charge means one charge. Bring a unit charge from one point to another point. That means there must be a work has to be done to bring a charge, unit charge, from one point to another point. That work is W, that unit charge is Q. So the potential is defined as the amount of work done to bring a charge from one point to another point. The SI unit of potential is volt. So as I am told that the SI unit has to be written only in small letter if it is a scientist name. The Alexander Volta is a scientist. So in order to honor him, we have to give the SI unit for potential. So volt is in small letter and V is in capital letter. Symbol is in capital letter. So students may ask that, sir, what is the difference between the potential and the potential difference, sir? The potential means the same formula V is equal to W by Q. So the amount of work done to bring a charge from infinity to the particular point is called as a potential. One point to another point is called as a potential difference. So again I will say that when the amount of work done to bring a unit charge from infinity, it is not a one point, infinity to the particular point is called as a potential, and the one point to another point is called as a potential difference. For potential and the potential difference, the SI unit is volt. Sometimes we will say that the potential or the potential difference. So the volt, the SI unit of potential is 1 volt is equal to the SI unit of work is joule. So 1 joule by 1 second. I will define that. Define SI unit of potential difference. The question may be asked means you don't define the potential difference. They are asking that define the SI unit of potential difference. What is the SI unit of potential difference? 1 volt. So 1 volt is defined as 1 joule by 1 second. Similarly, you can write that what is a SI unit of current. So define the SI unit of current. They may ask, that means the SI unit of current is ampere. So 1 coulomb by 1 second. So you can write that 1 ampere is defined as 1 coulomb of charge flow in 1 second. Now we will see that the voltmeter is a device used to measure the potential difference. What is the device used to measure the current? Yes, it is correct. Ammeter. So for the current measurement is ammeter. For potential difference, it is called as a voltmeter. So you remember that the ammeter is always connected only in series. Here the same thing, but it is in the opposite sense. It is connected only in parallel because the voltmeter has a high resistance. Or you remember why we are connected ammeter in series? There I will write that it is a very low resistance. Here I will write that very high resistance. The same thing I will repeat that for ammeter, why it is connected in series, why the voltmeter connected in parallel. Both the things we are going to see after the Ohm's law session clearly, because you should know that what is resistance, then only you are able to understand why it is connected in series. The voltmeter is connected in parallel and ammeter is connected in series. Students always face a lot of problems in the practical sessions. They didn't know how to measure the current in the ammeter. They are seeing the readings, they are seeing some needle, but they are often face the problem how to measure the reading. It is very easy, don't. So first you see the device, that if it is put it as a means it is a ammeter. So you see that it is a 0 initial reading and final is 5. So it is ampere A. So it is a 0 ampere to 5 ampere. That means the range of this ammeter is 0 to 5 ampere. So I am writing this reading is 1.7 ampere. Sir, just we see that it is a 1 ampere. This is 2 ampere. So it is a 1.5, 1.6, 1.7. So 1.7 ampere. So I will say that very clearly. So least count. What is least count? The least measurement of this apparatus is called as any apparatus is called as a least count. That means what is the value of the one division is called as a least count. For the centimeter scale, the least count is 0.1 mm. Now we will see that how we are going to measure the least count. First you see that 0, this is 1. How many divisions in between 0 to 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 divisions is equal to 1 ampere. So what about the 1 division? 1 division is equal to 1 divided by 10, that is 0.1 ampere. Now you count that. It is 0 to 1 is a 10 divisions. Here it is a 15 divisions, 16th division, 17th division. So the measurement can be done, that is 17 into 0.1 ampere, because 0.1 ampere is the least count, which is equal to 1.7 ampere. When the ammeter is given as a milliammeter, so M, if it is put it as a MA, means this ammeter is a milliammeter. The same reading, so what is the reading here? The reading is a 1.7 only, but not a 1.7 ampere. It is 1.7 milliampere, which is equal to 1.7 into 10 power minus 3 ampere. So it is very easy. Don't be afraid about how to take the reading in the ammeter. Now we are going to see how to take a reading in voltmeter also. In voltmeter measurement, I take a microvolt. So in order to explain how it is a milliampere, same as a millivolt. So microvolt, we will take the one example. So here you see that differently. 0, this is a small division, that's a 5th division, this is a small big line. Then at the 10th division it is given as a 2. So it is a 2 microvolt. So the reading is shown, the needle will shown in this position. So how we are going to take the reading? Before taking the reading, you have to calculate what is the least count. As previous session I told that first you have to count how many divisions. Here there is a 10 divisions is equal to how many volt? It is a 2 microvolt. For one division, you bring this 10 here, 2 by 10, which is equal to 0.2 microvolt. Then as usual, you move to here. So how many divisions it is? The needle shows the 14th division. So here it is a 10, 11, 12, 13, 14th division it is a reading. So 14 into the least count 0.2 microvolt. So it is equal to 2.8 microvolt. Micro means 10 power minus 6. That is 2.8 into 10 power minus 6 volt. So students, don't worry about how to take the reading in the ammeter and voltmeter in the practical session.